Welcome back. I am Anshu and you are watching Bottleneck. This is the Agenti AI cookbook series where we learn and implement design patterns for AI applications using hands-on examples. In our previous video, we implemented a custom support agent, which is an example of adaptive dynamic routing in Agentic AI. We discussed in detail about the use case and the multiple routing strategies. We also implemented ML-based and LLM-based router. In this video, we will continue with our implementation and create the embedding-based and rule-based router. Alright, so let's start with the embedding-based router. So for embedding-based router, we need embeddings, and for embeddings, we require data. So let's start with it. Embedding-based router. Alright, let's cook some data. Routes is equal to, all right, it's going to be a dictionary. We have three categories. First is billing. So what kind of data billing will have? Billing will have something like track order, okay, or it will have something like delivery, and payment, or delivery payment will come under, okay, yeah, payment will come under billing, okay, payment status, okay, or just make it payment, okay. Now for other categories, we have then technical. In technical, we will have bugs or bug, crash. We will have product features, framework related question. All right. Yeah. And finally, we have general, which will have the FAQs and general queries. So general queries, okay, FAQ or help information. All right. So these things will summarize our entire use case for the embedding based router. Now the next thing is we need to create embeddings. All right. So for embeddings, I have used the sentence transformer, and you can use any of your embeddings. I'm using Hugging Face embedding, but given that you have the LLM key, so accordingly you can use the embedding of your choice. All right. Let's initialize the embedding. My LLM dot no embeddings embedding model. All right, embeddings are initialized. Now let's vectorize the data. So routes vector or route vectors. All right, so now watch closely. We will use key and embeddings dot embed query, where we will be embedding the values. All right, which will come from key comma value in routes dot items. All right, so what we have done now is we are iterating through routes and we are creating a dictionary for key to the embedding vectors. All right, now next thing is calculating the cosine similarity between the user query and the vectors that we have. For that we require numpy, so let's import numpy. Okay, so we have already imported numpy as np. Okay, now let's go down here and let's continue. So let's create the method def cosine similarity. All right, Now it will take two values, A and B. One is the incoming user query, another is the vectors that we have from our routes. Alright. And this will return, watch closely, np dot a comma b divided by np dot lineage dot normalized value of a star np dot and again normalized value of b. Okay. All right. So this will be the cosine score for each value, and we will be selecting the most suitable value from, or the maximum similarity between two values, the value with maximum similarity. All right. So let's route, or let's write the embedding routers. All right. It's going to take a state and return a partial dictionary. So what it is? It is embedding based router to classify user query. All right. Now first is we need the query itself, so it is coming from the shared schema state with the value as query. All right. Now we need to convert this to embeddings, so we can say query underscore vector, so it will be vector. Now embedding dot embed query and pass the query itself. All right. So now this is being embedded. All right. So now we need to incorporate the logic to get the best route or the score out of it. So let's have the placeholder best route as none and best score as 1. These are the initial values. Now we will compound on this. All right. So let's compute for route comma vector in routes underscore vector. Here we had calculated this values dot items. All right. Now watch closely. We will calculate score every time. The score would be the cosine similarity. So it is cosine similarity between two values. One would be the query vector, query underscore vector, and another would be the vector from the routes that we have calculated. All right. Now let's track the route with the highest similarity. So how we can do it? If score is greater than the best score or best score, which we have initialized as 1, okay, then the best score is equal to score. All right, so we have swapped the values, or else, and the best route is equal to the route. Now or else it will state keep on holding the same value that it has. Now we have the best route and best score calculated based on the routes or the vectors that we have created. So finally we will return the best route. That's what our intention is. Okay, so return again a partial dictionary where it will be a route and it will hold the value as best route. All right, so here as we see, the embeddings are calculated using the embeddings from Hugging Face. We convert everything to vectors. We compare the vector using cosine similarity. And finally, we find the best score using the iterations. So there could be other approach or other ways to do it. And you are open to experiment on this. You are very much welcome. But let's move on to the rule based. All right. So let's write the rule based. It's going to be simple. Rule based router. Okay, so first let's put a comment. Okay, now it is also going to take a state same as before, and it will return a partial dictionary. So what it is going to do, a rule based classifier. Rule based classifier to to classify the user query. Okay, it explains everything. So what we are going to do, we need to have some rules. So what are the rules? We will hard code the rules as of now. We need a query that is coming down from the state, and it will have the value as query. All right, now we will have a quick check if any word in query for word in. Now we will feed some random values: order, delivery, shipment, or price. So it looks like it is billing, so we will return a partial dictionary with a route as billing. Now we will be returning similar values for other categories as well. So let's copy it down. All right, so let's copy it from here. Okay, and let's write else if and paste it. All right, so this time the words are going to change. It is going to be error, and it should be a bug, a crash, and not working. All right, so this will return technical. Now finally we have else. So anything that doesn't fit into these two categories shall return general. So it's going to be a return, again a route, and finally it will return general. All right, that brings us to the end of the part 2 of our customer support agent implementation. Till now we have implemented all the routing strategies, starting from the ML based to the rule based router. And in the next part, we will continue with our implementation to complete the workflow by defining nodes, constructing the graph, and connecting everything together into a fully functional agent. So stay tuned. If you found this video helpful, don't forget to like, share, and subscribe for more practical insights into AI architecture and design pattern. See you in the next video. Thank you.